In this video, I will introduce the basic function and concept about Wecon Servo drive. So let's begin. Here are the 6 topics we will go through in this video, including servo competition, wiring and signal definitions, panel display and operation, servo function, and the usage of debug tool, and the FAQ, and the troubleshooting. Wecon Servo drive is composed of the 2 parts, namely the servo drive and the servo motors. Here we talk some history about serve. The word serve derived from the ancient Greek word for slave. It means that the serve can move at a specified speed or distance. Before the signal arrives, the rotor is stationary. The rotor rotates as soon as the signal arrives, and when the signal disappears, the rotor can stop on its own time. Because of its servo performance, hence the name. At present, servo has become high precision, high response speed, high performance synergy. And this is the front panel of the Wecon Servo drive. Here is the high voltage indicator. And when this indicator is lit up, it means there is still remaining high voltage in the servo drive. So we shouldn't open or touch the servo drive. And here is the power input terminals. This is the motor output terminals, and this is GND terminal. And here is the LED panel, like most servo drive in the market. And this is the RS485 COM port, can support the Modbus protocol. And this is the RS422 communication port. It looks like a LAN port, but actually it's the RS422. This port is used for debugging. We can connect this port with our PC, and then we can debug. And this is the I/O connector, and this one is the encoder connector. Here's the encoder connector. Because it's a ready-made cable, so we don't need to solder the pin by ourselves. So we just have. And this is the I/O connector. Here we can see AI1 and AI2. AI1 and AI2 are for the speed reference and torque reference. Both signal ranges from -10 watts to 10 watts. And then here is the digital output port. This is the signal and the pulse signal port. Generally, these 2 signals come from the PLC, so we can use PLC to control direction and the speed of the servo motor. And here's the digital input. And this is the PAO, PBO, PCO. This is the so-called pulse division output. For example, when we input the signal to the servo drive, and we can get the feedback pulse from PAO, PBO, and PCO. So that's the function of the PAO, PBO, and PCO. And this is the RJ45 port. As I just told you, it's RS422. Because most PC doesn't have a COM port, so we need to USB to RS222 converter, and then we need to connect according to this diagram, and then we can debug the servo drive with our PC. This is the RS485 COM port for Modbus RTU protocol. And here is the main circuit wiring. Wecon Servo drive can support for single-phase 220 watt manpower or the 3-phase 220 watt manpower. So far, doesn't support the 3-phase 380 watt manpower. So we need to pay attention to this. And this is the LCD panel and the button. Just like most of the servo drive in the market, there are LED display and the fire button. The first button, we call it M switch. It's for switching between modes, or go back to the previous level menu. And this upper menu is for increased LED flicker bit value. and the down button is for decreased LED flicker bit value. And this button is for changing LED flashing bit of position. And the last one is the enter button for going to the next level menu or execute command such as storages parameter settings. Here are some common status message we can see in the LED. The first one is the 58. This message means the server drive is in initialization state. And the second is the INIT. INIT means the initialization. It means the initialization is completed. And the third one is the RDY. RDY means the ready. It means the server drive is ready for running and wait for the server on signal from the host controller. The fourth one is the run. Run signal means the server drive is in running state. And the last one is the jog. It means the server drive is in jog running state. And here are two alarm display. The first one is the A-84. It means we need to restart the drive to make modified parameters take effect. And error 34 means the motor is overloaded. And here are the 5 monitoring value. Here you can see 2000 and minus 2000. It means the actual running speed of the servo motor. Minus means the reverse direction. And this one means the bus voltage. It can display the voltage value between driver P plus and minus. And this one represents the level status corresponding to the 8 digital input terminals. The upper part of the digital means it's at a high level, and the lower half indicator means it's at a low level. This means the DI1, this is DI2, DI3, and so on. And U0-19 means output signal state. Just like the above parameter, the upper part of the digital tube indicates a high level, and the lower half indicates a low level. This one means the digital output 1, this one the digital output 2, and so on. Here I will show you how to control in the front panel. First we click the M button, and then we can see the P0.1. It means the first parameter 1. And we can use the up key to switch it to the parameter 2, or the down button to switch from parameter 2 to parameter 1. If we click the enter key again, we can enter the next menu to modify the value of the P1. And we use the up and down button to change the value. And then we use the enter key to modify the parameter. Here's one thing we need to pay attention. We press the enter key twice, it will blink for the first time and down for the second time. It means we need to press the enter key for 2 times, and then we can change the parameter successfully. Here's another example. If we want to use the jog function, first we need to access the P10.1 parameter and press enter key to display jog initial speed, and we use the up and down key to change the jog speed, and we press the enter key for 2 times, and then we change the parameter. Finally, we can use the up and down key to execute the jog operation. And here's another function we often used. so-called restore factory settings. First, we need to access the P10.2 parameter. We enter the key and use the up key to change the value to 1. And then press enter key again. And here we need to long press the enter key for 3 seconds. It will display DONE down. Means we has restored factory settings successfully. In this chapter are some relevant terms of the servo drive. The first one is the electronic gear. It means when servo receives one position reference, the actual displacement motor rotates or moves. Second one is the command unit. It's the resolvable minimum value input from the host devices to the servo drive. Encode unit. It means the value of the input command after processing by the electronic gear ratio. Frequency division output. Output position command pulse or the position pulse fed back by the encoder in AB phase orthogonal mode. This is the function I told you from the PAO, PBO, PCO. This is the position complete. Position deviation satisfies the condition set by the user. It can be considered that the position is completed in the position control mode. At this time, a position complete signal can be output to the host device. This is the position proximity. The threshold is larger than the positioning complete set value. Zero clamp, namely zero speed clamp. In the speed control mode, when the zero clamp digital input signal is valid, when the speed command is less or equal to the function code setting value, the servo motor enters the zero position lock state. At this time, the position control and the speed control are invalid. It will return to zero position even if it's rotated due to external force. As you may know, there are 3 control modes of the servo drive. The first one is the position control mode. There is also speed control mode and torque control mode. And we will talk the position control mode at first. Position control mode is carried out according to the position command from the host device, generally from the PLC. And the pulse number defines the distance, and the pulse frequency defines the speed. There are several pulse types. The most often used is the first one, pulse plus direction. One signal for output pulse, and another signal for control the direction signal. And this is the AB phase signal. AB phase, you can see here, AB phase signal has no separate signal for controlling direction, because for AB phase, it can define the direction according to the phase differential between phase A and phase B. When phase A is advanced phase B by 90 degrees, it means the direction is positive. Otherwise, it means the direction is negative. And the third one is the clockwise and the counterclockwise. This one is not used so often. It means that when the CCW signal is valid and the rotation direction is the reverse, and if the signal of CCW is invalid, it means the rotation signal is the forward direction. This picture shows the differential input volume for the position control mode. because it's differential input, so you can see two for one signal means pulse plus and pulse minus for one signal, and the signal plus and signal minus for one signal. Even less 4 watts, but there's actually two signals. One signal for pulse and one signal for direction. By using the differential input wiring, it can increase the anti-noise capability, so the wire can be longer and it will be more stable. And this is another kind of wiring is the open collector input. Because there's no 24-volt power supply in the servo drive, so we need to use the external power supply. For example, the host device is PLC, so we can use the 24-volt power supply in PLC, and we can consider this wire as the Y0 and this wire as the Y1. So Y0 control the direction, and the Y1 output the pulse to control speed. Now we talk about filtering. Position command filtering is to filter the position command processed by the electronic gain ratio, including first-order low-pass filtering and average filtering. Consider aiding position command filtering in the following three situations. First is the position command output from the host device is not processed for acceleration and deceleration. And the second is the pulse command frequency is low. The third is the electronic gain ratio is 10 or larger. And from this picture, you can see that the first order filtering has the smoothest curve, so that's the least vibration for the machine. The filtering time is not as long as possible. If the filtering time is too long, the delay time will be too long and the response time will be correspondingly extended. And here are three common loads, and for all the three common loads, we need to set different gain ratio according to the application. And now talk about the position mode. Position mode digital output. And first, position output signal is the position deviation. It's equal to the position instruction minus position feedback. Second digital output signal is the position complete. When the position deviation is less than the positioning completed function code setting, and then the positioning is regarded as completed. At this time, it will output the positioning complete signal to the host device. The third one is position close. When the position deviation is less than the positioning close threshold, and it will output a position closed signal. Now talk about the speed control mode. Speed control is based on the analog speed command input from host device or the internal speed command set in the servo. And there are three sources for the speed control. The first is the analog input, and the second is the communication. We can set value by the RS485. And the third is the internal mount speed control. This function is now reserved. Now we talk about speed-related digital output. After speed command is filtered, when the value of the servo motor speed reaches the rotation detection speed threshold, the motor is considered to be rotating. At this time, the digital output terminal of the servo drive can output the rotation detection signal. Conversely, when the actual rotation speed doesn't reach the setting value, it's considered that the motor is not rotating. Now we talk about the zero speed signal. When the actual speed of the servo motor is less than a certain threshold, it's considered that the servo motor stops rotating. At this time, the digital output terminal of the servo driver outputs zero speed signal. Conversely, if the actual speed of the servo driver is not less than this value is considered right. The model is not at rest until the zero speed signal is invalid. And in this chapter, we talk about speed consistent signal. When the absolute value of the deviation between the actual speed and the speed command meet a certain threshold, it's considered that the actual speed of the motor has reached the set value. At this time, the digital output terminal of the servo driver can output a speed consistent signal. Conversely, if the absolute value of the deviation exceeds the threshold, the speed consistency signal is invalid. Now we talk about torque control mode. Torque reference source include internal torque setting. Another source is the analog input, set by function code P1-7. And the torque command also have filtering setting. In torque mode, the servo drive could run smoother by low-pass filtering, which also reduces vibration of the servo motor. In this picture, we can see that the first auto filtering makes the curve more smoother. The debugging software running PC is used for the parameter adjust, and the setting may include the following functions: function code reading the settings, monitoring parameters, debugging interface for on-site trial operation, and the parameter settings. Viewform windows provide for channel real-time display for easy debugging. And so far, this tool has only Chinese interface. We will add English interface in the near future. This is the interface of the debug tool. Here's the function area. We can choose different function in this part. And here's the communication part. We can choose different communication port. And this is the state toolbar. And the green area is the main Windows workspace. We can change the parameter value here. And here we need to select the component first, and then click the connected device button. And we click this read parameter button. It will pop up window read successfully. And then we can see the windows in the list. If we double click the item, we can change the value. After changing the parameter, we can click this button to download the parameter to the soft drive. In the monitoring interface, we can set the refresh interval. For example, we set it as 500 millimeters. And we can also execute the manual operation. We can set the RPM here, and the maximum RPM, and the revolution we want to move, and the direction. And then we click the servo on button, and then the motor can start to move. And here's another function. We call it initial recognition. First, we need to make sure the servo travel range is up to 20,000, namely 2 circles. And we click the start button, start recognition button. When the recognition is completed, click yes to write the arguments to the EP long. Here we can see the initial ratio. And next, we can measure the parameters of the servo, like the position, loop gain, speed, loop gain, and the rigidity, and so on. And here we can see all the measured parameters, and we can click save to save the rigidity parameter. And here's the viewform windows. You can see there are 4 channels here, and we can define different functions for each channel. For example, real-time speed, and torque, and position deviation. And here we can save data or save as or take a snapshot. And here we can select the position control mode, the speed control mode, or the torque control mode. And this is the front quality windows. We can see all the windows all aligned here, and easy to troubleshooting. Now we talk about FAQ and the troubleshooting. The first question is the PC cannot communicate with the server. In this case, we need to confirm wiring is correct, and also check the driver. If the driver is not installed properly, and the communication will fail. And then last, we check the power selection. If the model cannot run, first we need to view the panel, check if the lights in the line in the LED display. And second, we try to use manual mode to run the motor. Third, we check the control mode and the command source. Last, we check the wiring, such as SON, POT, MOT. The third point is about some common malfunction. For example, the bus is under voltage. In this case, we need to check if the input voltage of the server is proper. And the encode issue, generally we need to check the encoder line, and sometimes we need to replace the encoder line. And the motor power line, sometimes the motor power line will be loose, so we need to tighten it, or sometimes we need to replace the power line. And the motor overload, in this case we need to check whether the load of the motor is too large. Check the deceleration time. Use the debug tool to observe the actual torque. See if that's overshoot. Function code exception. In this case, we can restore to factory reset to eliminate failure. And here are another 4-point question. The protecting rating of the servo motor is IP65. The servo drive is not. The function of virtual input terminal, for example, when virtual digital input 1 is enabled in the servo, is equal to we give a valid signal to the physical input terminal DI1. The default function of DI1 is servo on. Then we can make it without connecting physical wire to DI1. The sixth point, when servo on signal is valid, the jog operation in the LED panel will be disabled. We need to disable the servo on signal at first. And the last point, CN3 and CN4 can be used at the same time. That's no problem. So thank you for watching this video.